Hello everyone, welcome to summer internship program. In this video practice, I explore the basic field process involving trigonometric leveling, simple leveling, and inverted stuff leveling. In many civil engineering projects, trigonometric leveling is used to determine the height of the buildings, to determine the height of the tower, or this could be also the electric pole. Apart from this, trigonometric leveling is used to identify the relative height between point A and B in hilly grounds or hilly terrains. This relative height is necessary in a hilly ground when we are planning to new roads or when we're locating the sewage pipes or water supply pipes. Trigonometric leveling is carried out by using the total station, and this method is considered indirect method to identify the relative heights between A and B, because relative height here identified by using the observed azimuthal angle alpha and observed slope distance. Okay? Alternatively, instead of the trigonometric leveling, we can use simple leveling method to identify relative height between A and B. This is the point B, this is the relative height, by using the leveling instruments. In this case, leveling instrument is placed the half distance between A and B, and we hold our leveling rod on point A as a backside point and take the reading R1 and rotate the leveling instrument toward the foreside point and change the leveling rod to the point B and take the R2. And the relative height will be equal to H equal R1 minus R2. Here, definitely we will get plus value because R1 is higher than R2. That means if we go from point A to B, we are rising, or the elevation is rising. This plus sign shows this. Okay. If relative height is very high, or the distance between point A and B is very long, we use differential leveling instead of the simple leveling. In differential leveling, we divide this distance point A, point B, approximately equal parts. Then we install the total leveling instrument between these rods and calculate relative height between all points, and finally get the relative height between A and B. So now I'm not going to discuss about differential leveling, and I've just explained it two methods. The first direct, indirect method, and the second is direct method to calculate the relative height between A and B. So both methods have advantages and disadvantages, but today I'm not going to discuss which method is better. Instead, I'm going to show you how these methods are carried out in a real field practically. Unfortunately, in our laboratory, we don't have a hill like this, but today this table play a role as a hill, okay? And today we're going to determine relative height between point A, this is A, and point B. Can you bring the camera? So this is the point B, okay? So today experiments, we use trigonometric leveling and simple leveling method to identify the relative height between point A and B, and after that we compare the results, compare the both relative heights, and we will see at the end of the experiment, we will see how these relative heights are close each other. In ideal condition, the relative height should be equal, but we have several errors, systematic gross errors and random errors. Due to these errors, we will have some discrepancy between two relative heights. So we will see this. So the first, I identify the relative height point A and B by using the simple leveling method, and I use the leveling instrument. The first, I have to identify the distance between A and B, and I use roller, and my colleague Daniel will help me. Please. Okay. And the distance between point A and B is approximately 4 meters. So I have to identify the half, and half will be the 2 meters. And 2 meters is approximately here and here. And now I have to set up my leveling instrument on points over this mark, and this is will be this point. And in our case, half distance is 2 meters, and this is 2 meters. Okay? So we have installed the tripod, and we use the star because our floor is the slippery. So now it's ready to put the leveling instrument, and the tripod head level is almost parallel to the floor. And this is my leveling instrument. I tightening the screw and I connect the leveling to the tripod. The leveling instrument has a circular air bubble, and by using this I can make the fine adjustments, and I use these leveling screws. Now the air bubble is, you see, in the center of the circle, so we can finish the leveling process. So my leveling instrument is ready to take the measurements R1 and R2. So the first, I take the measurements from the A as a back side. And I use the leveling rod or staff. So this is my leveling rod, or we can call also the staff. So this staff has two sides. This is the barcode side, and this side is graduated with centimeters. Okay, I can use both sides. So someone should hold this staff on point A. So my colleague Daniel will help me to hold this vertically on point A. Okay. Okay. Please hold the staff vertically, but not here. Vertically, okay? So I look through the eyepiece of the leveling instrument, and I create a line of sight, horizontal line of sight, and if when this line of sight intersect with the leveling rod, so I can take the measurements. So now I look the eyepiece of the leveling instrument. So I got the first measurements from backside points R1, and my R1 is equal R1 is equal 1.514 meter. 1.514 meter. So now I turn the leveling instrument to the direction of the point P, and I bring the leveling rod, and I put the leveling rod on point B. So please hold the staff vertically as much as possible so that I focus the leveling rod. So my second measurement from 4 side points, R2 is ready, and it's equal to, can you focus on display? It's equal to 0.76 meters. Okay? So R2 equal 0.76 meters. Okay? Yes. Then I have to subtract these two values. Then I can determine the relative height. So H is equal 0.514 minus 0.76. So the relative height will be equal to 0.754 meters. So now we have determined the relative height point A and B.